text justification in JavaScript. This is a hard problem. It's very tedious and messy with little edge cases and things to watch out for. Given an array of strings, words, and a width, max width, format the text such that each line has exactly max width characters and is fully, left and right, justified. You should pack your words in a greedy approach. Pack as many words as you can in each line. Pad extra spaces when necessary so that each line has exactly max width characters. Extra spaces between words should be distributed as evenly as possible. If the number of spaces on the line does not divide evenly between words, the empty slots on the left will be assigned more spaces than the slots on the right. See what I mean by being annoying? For the last line of text, it should be left justified and no extra space is inserted between words. Another edge case. A word is defined as a character sequence consisting of non-empty space chars. Each word's length is guaranteed to be greater than 0 and not exceed max width. The input array words contains at least one word. So if the max width is 16, we can put 4, and then we can put 5, 6, 7, 8. Our next word would be example 9, 10, 11, 12, 13, 14, 15. And we'd have to have these spaces. So this is 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. Sorry, 12, 13, 14, 15, 16. Yeah, so we don't have enough spaces on this one. 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. We would need 2 extra spaces for that word. So that way we can only get this is n on the first line. And the next line we can start out with example. That is 7 letters. The space or the comma is 8, 9, 10, 11, plus 4 is 15. And that'll fit on there. And then the last word, justification, and a period followed by a number of spaces here. Now we look here, example has 2 spaces and then of has 1. And that's how that one's padded. And all that's taken care of in a separate function called format line. The way I divided it up is to create lines where we can have each line will fit the number of words. Okay, so now we've got each line format. We've got each line with the correct number of words on it so that it will fit those number of words with the spaces between each word. And then we're going to have to go through and format the line in a second approach. And I found this divide and conquer strategy for formatting the lines would work better for me. So we could see if the line can accommodate another word. And if it does, then we can add it onto there. So here's our function. If we have no words, return an empty string. Well, I don't think that's ever the case. So we have to have at least one word. So that's never going to be the case. So we can just get rid of that right now. Lines is words.shift. Shift takes an element from the front of the array and modifies the input array that it's called on. So now words has 1 fewer line in the beginning. So we're not going to start our loop on the first word, this. We're going to start on is. We loop through I is 0, I is less than words.length, I plus plus, W equals words I, which is because we shifted 1 off the front of the array. Current line is lines 0. Current line is 0. And we're going to increment that later. Line min length this is the fastest way to do this. Oddly, keeping track of the number of characters in each line was a lot slower than actually converting it to a string and getting the length property off it. So what we do is we convert that line array into a string and get the length of that string. Now that line array formatted as a string is going to contain commas. Those commas will have the same length as a space character. And we can see that to be the case if we go something like, if we go string, and then we pass it an array, hi, by, we pass it a string array, and then we call that, we're going to have a comma in between hi and by. That's the way JavaScript has been standardized and can be expected to format an array. It will format it with that comma there. And this happened to be the fastest way to do this. Oddly, it was much faster than counting and keeping track of a number. You wouldn't think it would be, but it was. And we're in the upper 90 percentiles, like 96 to 99% performance on this. So this beats all. Has room, that's a Boolean. You always name your Booleans with has or is. Usually, sometimes you want to use can, but has or is. So has room is the max width. That's what we passed in this case it's 16. Line min length minus line min length, which is calculated to the current line's length, being greater than the word length. Now, the word is the next word. So right now we're on this. We have this in our array. Our current word that we're testing is. Do we have room to put it in there? So yes, we do. Obviously, we know that this is 4. Max width is 16. Minus 4 is 12. And well, so then that's going to be greater than the word's length that we're checking. We're trying to put is in there. Right. So it has to be greater than, not equal to, greater than, because we need that extra space in there. If we have room, then we push that word onto the current line. And we keep doing that. So we push is on there. So now we're going to increment I. I is going to be 1. This is 1, because remember we sliced this off the front. We shifted this off the front. So this is 0. This is 1. So now we're going to convert this to a string. 1, 2, 3, 4, 5, 6, 7, 8. Do we have room for 2 more characters? What's 16 minus 8? 8. Obviously, we have room for this word in here. Okay, so now we have 2 more characters in there. So now we have 10. And we increment I. Line is this is n. Now we're going to try to add example. We've incremented I. W. Here, words I is example. Example has 7 characters in there. So do we have room to add to the current line? So we have 4, 5, 6, 7, 8, 9, 10, 11. 16 minus 11 is that right? 4, 5, 6, 7, 8, 9, 10, 11. Or 10, sorry, is 10 minus 7 is 10. 16 minus 10. 16 is max width minus line min length, which is 10, greater than w dot length. No, 16 minus 10 is 6. The word's length is 7, so it has to be 8. So we would have to have, instead of 6, we would have to have 8 characters remaining to get that word on there. So we don't have room. So now we have to see if the next line, if it'll fit on the next line. When we do that, we're going to format the current line, and then we're going to check the next line. And then when we're done, we're going to format the last line. We're going to basically join it together on the empty string and then pad it max width with the empty string. And these string.repeat and pad end really came in handy. The current line is then formatted. We pass in line and the line min length. And the line min length is just the line's length plus the word gaps. The extra spaces is the max width minus the line min length plus the word gaps. So how many spaces do we have to divvy up between those word gaps? The line max width is 16. The line min length is, 10. And the word gaps is going to be, let's see, was it 10? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So we have 6. 6 plus the word gaps. So 16 minus 10 is 6 plus the word gaps is 2. So, because remember we have line min length already includes those commas as if they were spaces. So now we can get the pad size, the extra spaces divided by the word gaps. But we don't want a decimal point in there, so we're going to have to floor that. And then the extra spaces are going to be the extra ones. So extra spaces are the word gaps plus the pad size floored. Extra spaces minus extra spaces are the number of extra spaces minus the word gaps times the pad size floored. The word gaps, if we have, in this case, we have 2 word gaps, and the pad size floored was, what did we say? It was 4. So we don't have any extra spaces on the first line. It's evenly divided with 4 on each one. And if the line length is 1, then we do this. It's not 1. So in this case, we loop through. For I is 0, I is less than extra spaces. We don't have any, so that's 0, and we just skip right over that. And then we join those on, because we're going to go greedy if we have a case where we have extra spaces. We're going to go greedy and left left prefer those extra spaces. And we're going to add each one to each word, and then we're done with that because we skipped over that on this iteration. We're going to join that line on the empty string, repeated by the pad size floored. Okay, so we join that by the repeated by the pad size floored. So we repeat the empty string, and how many times did we say the pad size floored was? Did we say it was going to be 4? Right, because extra spaces. Pad size floored is the extra spaces divided by the word gaps. 2 word gaps, 8 extra spaces. Floored is the same thing. It's still 4. And then we're going to repeat that. We're going to have 4 spaces in between each one. And we can see that if we log that out to the console. And we're going to continue this algorithm in the same manner until we get to the last line. And in the last line, we're going to have to reformat it. The cur line is the last line, so we don't actually reformat. We just increment it here, and then we terminate the loop. Cur line is format last line, cur line, and we can see the input to that when we go down here by just console.logging, see what that gets. And we'll show you the line before we format it, and then we'll just add those extra spaces. So that's the last line that we have. Now we have to add those extra spaces on there. And the way we do that is with the string.prototype.padEnd, max width, and then the empty string. And the pad end takes care of that formatting for us. So there's how to solve it. And here's the performance that I was getting out of this, which is, like I said, in the top percentile range. As for memory, not so bad either. There you go. There's another LeetCode hard problem, a very annoying one, solved creatively with advanced knowledge of JavaScript. I didn't look at any of the other solutions. I just dove right in and solved it by using my knowledge of JavaScript. And I hope this helps. And take some of these lessons from this JavaScript example and apply them to your own code, particularly those string prototype methods and the technique of converting an array to a string. That can come in handy.